This player has a scene node, a position, editable properties, saved files, behavior code, and a run result. In the next few minutes, you will find all 6 in the real Godot editor and know exactly where to look next. Open the restored Chapter 1 checkpoint from the previous lesson in Godot, version 4.7 stable. We will inspect the project exactly as it is. Selecting nodes, opening panels, and running the game do not rewrite its authored files. And AI changes nothing in this lesson. The allowed scope is read only. Do not memorize the layout as 6 random names. Give each region a job. The scene doc answers what exists in the open scene. The 2D view answers where it is. The inspector shows settings. FileSystem locates saved resources. Script shows behavior. Output and debugger report what the engine said during a run. Start in the scene doc at the upper left. Playground is the root of this open scene. Ground, bounds, and DemoPlayer are its direct children. This list is a node hierarchy, not a folder browser. It tells you what the running scene is made from and how those nodes are related. Indentation carries meaning. Left edge, right edge, top edge, and bottom edge are children of bounds. Player shape is a child of DemoPlayer. Ground and DemoPlayer are siblings because they share playground as a parent. When a beginner asks, what objects are in this scene? This tree is the first answer. Select DemoPlayer. Godot now uses that same selection across the editor. The scene doc names the node. The 2D view marks its location, and the inspector switches to its properties. Select player shape next. Its circular collision outline appears at the same place, showing that the shape belongs to the player rather than floating elsewhere in the scene. The center workspace is the 2D viewport. With DemoPlayer selected, frame the selection and keep the arena visible for context. The transform marker sits at 480, 270, the center of this 960 by 540 play area. The viewport answers location and spatial relationship. It does not explain behavior. Here the editor can show the saved collision shape, but the blue player is drawn by code when the project runs. That distinction matters. A selection outline proves where a saved node is. The running blue circle proves what this script draws at runtime. Do not treat an editor highlight as gameplay proof. The inspector at the right is selection-driven. Click ground and you see ground properties. Click player shape and you see its shape resource. Reselect DemoPlayer and the player properties return. If the inspector seems to have lost a setting, first check what is selected before assuming the project is broken. With DemoPlayer selected, the exported speed setting is 240.0. Under transform, position is 480, 270. The script field references ch01, DemoPlayer.gd. These are 3 different facts about one node, a tunable script value, a location, and an attached behavior resource. Read them. Change nothing. The FileSystem doc lists files and resources inside this Godot project. res:// means the project root. It is not a public name for your computer drive. Inside it, the scenes folder holds the scene resource and scripts holds the player code. Project relative paths are the safe, portable paths to use in a tutorial or a bounded AI request. The open hierarchy is saved in scenes. ch01, playground.tscn. The DemoPlayer node is part of that scene and references scripts. ch01, DemoPlayer.gd for behavior. The scene file and script file do different jobs. One stores scene structure and node data. The other contains GD script code. Follow the visible references instead of guessing which file owns a change. Double-click the player script. Godot switches to the script workspace without leaving the project. The first line says this script extends character body 2D, matching the DemoPlayer node type in the scene doc. That agreement is a useful sanity check. You open the behavior attached to the node you meant to study. The exported speed line supplies the inspector value of 240.0. During each physics update, input.getVector reads the 4 arrow actions. The next two lines also accept the W key, the I key, the S key, and the D key. The script limits diagonal direction to length 1, multiplies by speed to set velocity, then calls move and slide. Read this as a sequence: input, direction, velocity, movement. The draw function explains the player's appearance. One call draws the filled blue circle and the next draws its light outline, both centered on the node's own origin. The script view explains the intended behavior and appearance. Only a real run can show that those lines execute successfully in this project. Press Run Project. When the Nightbloom game view opens, click inside it so the game has keyboard focus. The blue circle appears at the sage center position. That connects the scene node, transform, attached script, and draw function to one visible runtime result. Press right, down, left, and up. The key display follows the real input while the player moves through the arena at normal playback speed. The enlarged player and short trail come from this same take. They make a small subject readable without inventing motion. Movement is the proof that input reached the script and move and slide produced a result. Stop the project and open output. This panel shows messages produced by the engine and by print calls in your code. This script has no print call, so it does not write a line for every key press. Preserve whatever the real run shows. Never add a fake clean log, and never mistake silence for movement proof. Debugger is the neighboring diagnostic view for errors, breakpoints, and run information. Read the error and warning state that Godot actually reports. A run with no reported error means only that the engine did not report one in that run. The movement you just watched remains the behavior proof. Diagnostics and gameplay answer different questions. If speed disappears, do not start changing files. Look at the scene doc. We selected ground, so the inspector correctly shows ground. Reselect DemoPlayer and speed returns. If the bottom panel is hidden, click Debugger to reopen it. These are navigation states, not damaged project data, and neither repair requires an AI or a code edit. Now repeat the route without the map. What exists in this scene? Read the scene doc and select DemoPlayer. Where is it? Follow that selection into the 2D view and frame the center transform. What settings does it have? Read speed, position, and script in the inspector. 3 questions, 3 visible answers, and no project change. Which resources preserve it? FileSystem shows the playground scene and player script under res://. What makes it act? The script workspace traces input to velocity, movement, and drawing. What happened when it ran? The game shows movement. Output and debugger show the engine's messages and diagnostics. That is the complete route from a selected node to a tested result. You now navigate the Godot editor by question. Scene, 2D, inspector, FileSystem, script, and output with debugger each gave one specific kind of evidence, and the project finished unchanged. Next, use that map to build the first arena scene tree and test its structure in a real run. This tutorial follows the first half of Chapter 2 in Make Your First Godot Game with an AI Agent. The book gives you the exact click path, labeled figures, recovery checkpoint, and the complete sequence behind this editor tour. The book and companion materials are linked below.